stop the stream?
I think I did stop the stream. Oh
Oh
gosh.
no.
All right, so we gotta start over. What are we doing?
Yeah, you can just click start again and it'll be fine.
It's okay. It started, and I'm in studio mode.
Click the start virtual cam. Is that down there on the right?
Okay. Yep.
Start virtual cam, and then on Discord.
Okay.
Oh shoot, I'm sending you in loops. I'm sending you in loops right now.
Right. Okay.
I'm sorry. The stream. Try going back to what you were doing. Let's see if the stream works now. Just go back to what you were doing.
Okay.
All right, now it's working, guys. Right? Yeah, we can see your screen.
Okay.
Perfect.
Cool.
We're back at it.
We're back at it. All right. Good deal. So, creating this emotional experience, I think places where we could improve that beyond necessarily like Amaru would be with the curiosity. So we definitely created this system in Amaru where there are these mysterious items in the world of Enso, and when you explore, play the games, it unlocks these over time. We created a system where when you solve puzzles in Puzzle Parlor, it unlocks little lore as a reward about the concept art development process. So we try to reward that curiosity. But I'd love to have that be more of a real-time experience. So yeah, I think that with this next project, we want it to feel less like an app and more like a game. And we want to have that curiosity being rewarded in real time, that challenge happening in real time, and we want to up the fun factor. So that's what we're setting out to do today with this. There's a lot of different ways that we could go about this. So we were brainstorming some styles. We talked about match threes, 2D side scrollers, 3D adventure puzzlers. So it's like a lot of different ways we could go with this, ultimately landing on the 2D side scroller. So that's what we're working on today. Totally not at all confirmed what this game is. It's definitely not confirmed to be Amaru 2. Never say that. It's not. It's not canon. So yeah. Then we decided to jump into prototyping just some very basic things literally in Miro. So Miro is just a giant interactive whiteboard. It lets me play with all sorts of stuff. And we started by talking about identifying and interrupting dominant strategies of a core game loop. So a core game loop in a 2D action side-scroller game is make your way from the left of the screen to the right of the screen. Pretty standard. But then we started putting obstacles in the way. We started introducing enemies. And over time, we brainstormed, really in, less than an hour, a number of different mechanics that could all be mixed and matched to create what's called emergent gameplay. And emergent gameplay is the best thing that can happen in game design. It's where a base set of simple rules start to come together in an infinite number of patterns, and it keeps the player flowing and changing and reacting to the situation. So we started with our little Simba here. There he is. We started with Simba, and Simba was able to move uninterrupted along the ground. We introduced some blocks, which forced him to start jumping. We then started to make it so that there was higher stakes for failing a jump. We started to introduce enemies that had different victory conditions. So we started with this guy, and we determined that because he has a sword, walking into him would hurt you, but you could jump on his head, and that would work just fine. But then we were like, okay, we identified the dominant strategy there, jump on the enemy's heads. So what did we do? We introduced a character with a helmet to interrupt that strategy, and now the player has to do something new. So these are the basic building blocks of design that we're doing here: is create a core game loop within a certain emotional context, identifying what the dominant strategy would be for the player to solve the problem, and then introducing challenges to overcome that problem. All in the context of what's called the flow zone. So the flow zone, when we're designing games, we want there to be a balance between the ability and the difficulty, the ability of the player, the difficulty of the situation. If you've got difficulty that far exceeds the ability of the player, they get frustrated. It's not a lot of fun. If you've got the game where the ability is far greater than the difficulty, they get bored. So what we want to do is we want to get them into the flow zone where there's a nice match between ability and difficulty. And we want to stretch them a little bit. We want them to kind of wave in and out of this thing. Sometimes the game's a bit more frustrating, and then it relaxes, and they can get to play with what they've earned. And we keep them in this flow. That makes it so they don't get in a place between being frustrated or... So, that is where we left off last time. This time, today, we're going to be struggle busting together through a Unity tutorial because I have basically officially reached the point where I'm not going to be able to take this concept any further in Miro. We do need to get this thing into a game engine at this point so I can start playing with the physics. Why is that? Because in a 2D action adventure game, literally the entirety of the experience is going to be determined whether or not it is fun to move. Before the designers at Nintendo went and designed 8 worlds of Mario, they put that little Mario character controller in a box and they just made it run around and bounce around and made sure it felt really fun to move that character. Because if they want the player to play the game across 8 worlds, it better be fun to play. So we need to get to a place now where we can start to prototype and tweak a physics controller so that this character feels fun to play. So that's what we're going to be doing today. As with always when one's following a tutorial, we can expect things to go wrong. And it's all going to happen live. So you can laugh and groan along with me while we try and build this little sandbox so we can start getting this 2D character controller in place. One final note in the guy whose tutorial that we're following today has talked about this is we're going to be going with some really low fidelity art. The reason we're going to go for low fidelity art is kind of twofold. One, I'm not an artist, and I could sit here and try and make really good art, but I promise you, I'll bet that Lexi or someone's going to do a lot better of a job when it's time to do the art. Let's be real.
Let's be real. Half of Amaru fam.
Yeah. Half of Amaru fam is going to do a better job than me at trying to draw this game. But also, what you'll find is that by using really lo-fi art in the beginning, it completely releases you from trying to make it look good. Today is not about making it look good. Today is about making it feel good. Today is about getting features in place and functionality in place. That's going to allow us to start to really just be released from the notion of making it look good so we can just get it to feeling good. And then also, if you've worked on a team, any sort of team where you're working with artists, like you never just say, draw me an Amaru sprite. You have to say, draw me a 1080 by 1080 Amaru sprite that's oriented at 45 degrees, that's going to interact with this when this button is pressed, and I need the frame rate of that animation to be this. You have to define all of those technical parameters, or else you're just going to send your artist into doing a bunch of art that they're not going to be able to use. In fact, we need to do this at some point, Sam. We need to show y'all the catastrophic failure that was the attempt at creating a ending sequence for the Stack Stone game. We probably could make a video of it. We had this adorable thing.
That'd be fun.
Where Amaru would fly onto the screen and then land on the top of the cairn. And then if the player chose, they could choose to have Amaru swing in from the side and knock the cairn to the ground. And we designed this whole thing and it was beautiful, but there was a missed handoff between the developers and the artists in that sequence, and the art was completely unusable. And now, we probably spent a month on it.
My gosh.
We probably spent a month.
Oh my gosh.
A month trying to build that, and completely unusable. And to this day, Puzzle Parlor Climbing Cairns has no ending, which is a tragedy because it was pretty cute.
To what, climbing?
The Stack Stones game. Yeah, so right now at the end of the Stack Stones game, you just get a score and that's the end. But Lexi animated a lot of frames of that guy swooping in, and we had it hit the collider of the stones, and the stones flying everywhere. It was super fun, and we couldn't use a damn thing because we didn't.
We should document that. As examples.
Yeah.
So wait, I have a question real quick.
Yeah. Mm-hmm.
From, in case people don't know, what is a sprite?
Okay. Yep. Absolutely. And you know what? That's a great place to kick over. So let's do that. I can find out how. All right, y'all see in Unity?
We see OBS right now.
See OBS right now.
Yeah, it's Unity. Double click on the Unity one on the right. No. Go back to there where you just were. Click on Unity. You did it. Double click on it.
Wait, this one?
Whatever one you had Unity on. That one.
Yeah.
Double click on it.
I did.
Select the drop down. It is Unity?
Yeah.
Okay, but you just needed to switch back to Unity.
I just need to hit
Yeah,
transition.
transition. Yeah, transition. There
Oh,
you go.
that's what it was. Okay, great. Okay, so now you're seeing that. All right, great.
Mm-hmm.
Cool. So,
Yeah,
all right.
it's working really well.
All right.
Every single stream has some hiccups.
Yeah, and I mean, I'm not going to beat myself up about it too much because this is the first time I've ever done this ish. All right.
Okay, now we have it on the right side.
You do.
Yeah, that's because you're using application capture for the big one and window capture for the small one.
Oh no. Okay.
This is so much fun to me, actually.
All right.
Okay, so the right side, we see OBS.
Why?
So just go in the bottom and change that to application capture. You want it to be YouTube?
No, I'm sorry. Hang on one second. The first thing I want to do. But this is
yeah.
okay. The first
is
thing
make whatever's on the right an application capture instead of a window capture, unless you want it to capture your right monitor and whatever you have up there.
Okay, hang on. I'm gonna take a breath. I know everyone.
We see you too.
I'm gonna take a breath and just try to build this thing where I need it to be.
It's better to do all the like troubleshooting now, so the next one will be like you'll understand it all, as opposed to trying to do a little troubleshooting every stream. Which you'll have to do anyways. Spoiler alert.
All right, so right now you should be seeing my big old face on the left and OBS on the right.
Right.
Okay. So
and somehow chat too, but we won't talk about that. Oh no, that's just because of OBS.
Just or Discord rather. But
yeah, Discord.
Okay. Well, in that case,
I like it, but I can't see the game design.
Yep. No, my big old face is not what we're here to see.
If you have questions, let me know. Otherwise, I'll just I don't know what's going on, so I'll just let you struggle through it.
Yep, that's fine.
Thankfully, you have the most patient and loving community watching you. So
everyone just take a deep breath in through your nose and out through your mouth.
This is a great time to do that. Yeah, everybody practice some of the breathing techniques while we can encourage Gabe
Always
here.
struggle bust my way through.
Yeah.
This. Okay, so
Gabe, take a deep breath. Take a deep breath, Gabe.
All right, so we're gonna do this.
Don't see you breathing. We can see your camera.
I breathed. Okay, so I'm gonna transition. That's brought Unity back up, and now so okay, so that's what's happening. So it's doing left monitor on that side instead of right monitor. So that's the issue.
There you go.
Okay, so big monitor. If I mute that, nope.
I need to get some water now that I'm thinking about my own self-care. Oh no, I didn't say hi to someone and they left.
Oh no.
No, who was it? I just totally missed it.
Okay, so now I just need to bring YouTube up.
There you go. That looks good. I think we're good to go.
Okay. My ADHD brain cannot handle the lack of object permanence. When stuff goes away, I just assume it's not working. All right, so that's OBS. Cool. Unity up here. All right, so what's a sprite? That was the question. What is a sprite? A sprite is going to be just basically the 2D rendered visual thing on the screen that we're going to be interacting with. And so this can be tiles for your player to jump on and walk through, etc. It could be your character sprite. And so working with the tutorial that we're about to watch here, this is actually literally just the stuff that we went through. And so this is interesting. When you are... Oh, and also the tutorial guy was supposed to give me a sheet of sprites to work with the project, and I've looked through these links very heavily, and I do not see a link to that. So I went and found my own, which is also a good side to promote freegameart.com. I can type opengameart.com. So if you're not familiar with opengameart.com, this is a place where you can just really search for a bunch of free to use art. So I came in here and I just typed in 2D side scroller. and I was able to find a number of just free, assets that people have put out there for people to use, and they have different styles. So some of them are more Mario like, some of them are more, space or whatever that is. I actually found a really cool one, this mystery set that y'all can see on the Unity screen here. Wanted to that opens a different program too. Okay, good to know. So it's actually pop up on the right side, but you can see it makes this little map of these different tiles that can be put together in different arrangements. And so if I wanted to, I could just start dragging these onto the screen. And I know everyone's OCD is going to freak out. Don't worry about it. I'm sure that there is like a snap to grid that I can do with this when I get going.
This is a Sprite. You have every right to get upset over this pun. Posted an actual Sprite bottle.
Somebody posted a Sprite. That's fine.
Yeah, Con.
Yeah, I think I'm going to have to triple screen this going. Don't really know what I do. But yeah, so that's what a Sprite is. And so an interesting thing about that is that when a Sprite is given to you, it usually comes in what's called a Sprite sheet. So... all right, so on the right-hand side, you should be able to see this kind of Mario pipe-looking thing. I'm hoping everyone's seeing that. I'm trusting everyone's seeing that.
Yeah.
And what you then do with that is you go into Unity and you go to the sprite editor.
It's half the screen though, because you didn't.
I figured as much.
Yeah, it's all right. We can see some of it.
Okay, but you should see this on the left now. So on the sprite editor, what this allows you to do is when somebody gives you a sprite sheet, you can set how big the tiles are on it, and then you can hit slice. And what that does is it cuts it up into the different pieces that you're getting. So a lot of times when somebody says, give me a sprite sheet, it means everything in the game kind of scaled together so that you can put it in the engine and slice it up. So that's what we just finished doing. And I'll also take one last thing. I'm honestly just stalling because who knows what's actually going to happen when I try and do this next step and how it's going to go. If anyone doesn't know what a game engine is, there are two really big ones. There are many out there, but two really big ones that people can use that are free. So you can just go ahead and download them and start playing. KMR asked what version of Unity this is. This is 2020.3.27F1. I will put that in the chat real quick. .3.27F1. Oh, wow, all the puns today in the chat.
I love it.
All the puns today. So a game engine is basically where all of the different pieces of game come together. It's got camera systems, it's got physics systems, it's got graphics systems. And think of it as like if you were building a board game and you had a big box full of all of your scissors and paper and cardboard and everything that you would need to make a board game. Think about that, but virtually, and you've got basically what a game engine is. And so the two big ones out there that you can get that are free are Unity and Unreal. Unreal is made right down the road from us at Epic Games. You may have heard of this little game called Fortnite. You may have heard of a little game called Gears of War. So this is Epic Games, and some people don't know about Epic Games is they make the Unity game engine, the Unreal game engine, which honestly is becoming a huge force, not just in games, but also in Hollywood. It's just an incredible, simulation and physics and effects machine.
Wow.
So a lot of times,
I didn't know that.
Yeah, a lot of times when you're seeing all of the crazy CG and Marvel movies and all that sort of stuff, like some of that is being made really just right there in a game engine. So that's becoming more and more common. On the flip side of that is Unity, which is what we use. We figure if it's good enough for Hollow Knight, it's good enough for us. But the major difference between, at least as an amateur, Ryan could talk a lot more about this in depth, but the major difference between whether or not you might want to pick Unreal versus Unity is Unreal is really optimized for big teams. It's got lots of stuff in the box already that are sort of presets and defaults. It's sort of expecting you've got a giant team that's working on stuff, so one person can really get into the lighting, really get into this or that. But it's also got a lot of these default settings, which allows people to get up and go. Unity is kind of the opposite. Unity is more like we give you this base starter thing, and then instead of giving you a bunch of defaults to turn off, we give you a bunch of modules that you can bolt on. So it's a little bit better for smaller teams. It's a little better if you're trying to create something that has a unique look and feel from the ground up. But it's also not going to look as sexy and sleek and shiny as an Unreal project with all the presets turned on. So we're in Unity. That's what we're working on today. All right, so now we're going to really, if we weren't flying blind already, we're going to keep flying blind and continue with this tutorial and see what's next. Because my goal by the end of this is to have a physics object bouncing around in a box that I can start prototyping my movement with. So let's see what there is to do next in this tutorial. Oh, and I just realized, Sam, they're not going to be able to hear the audio on the stream out of this unless we set that as an audio source, aren't they? There, Sam, did I lose you? Try real quick. Audio input capture. Audio output capture. That's probably what we want. No, audio input capture. Let's try that. Nope, that's not going to do it here. Things you learn when you try and stream on the fly. And Sam has abandoned me. Alright, well, I'm going to do the best I can to narrate what it is this person's trying to do. We're just going to keep flowing with it. That's how it's going to work. Alright, here we go. So, we've just finished slicing up our sprite sheet. Let's figure out what happens next.
XJet said Godot and Game Maker Studio as well. I think they're talking about game engines.
Yep, game engines. There's also one called Godot. Yep, there are many coming up there. All right, so Sam, we might have yet another technical problem. Which is that I can no longer hear the audio from the tutorial I was trying to listen to.
What's the problem?
I can no longer hear the audio from the tutorial that I was trying to watch.
You can't. That might just be an application issue. Right click. Is it muted?
I'm gonna reload and see. I ain't getting anything.
Did you change your computer output?
Wait.
You know how to go check your computer's sound output?
All right, that part that is now fixed. I've got that fixed. They're not going to be able to hear it. I guess I'm just going to have to narrate. Or can they? Can they hear it?
I think
they should hear your desktop audio.
So it doesn't blur any of the edges and makes it a bit easier. So you see we got the...
All right, so y'all were hearing that just now?
I got to turn it up, maybe.
Ground textures here. We got there's a white texture. We got a amazing block.
Yes.
You can hear that?
Question mark block. Two little legs and a...
Not in here, unfortunately, but that's a totally different issue. You would have to share application on here.
I figured as much.
And then switch back to screen. So,
okay.
You could just post the link for the YouTube video in chat.
Man, we're figuring it all out today, everyone. All right.
Are you gonna try to do it?
I'm gonna try and do it.
Okay, so you need to change the application.
Application audio.
No,
capture?
I'm sorry. In Discord, don't change anything on on OBS. It's working. The stream sees it.
All right.
Well, the stream can hear it. On Discord, you gotta change your screen share at the bottom to application share. Change window. So on here, choose the YouTube video. Now we'll be able to hear it. Okay, so we can't see anything else, but we can hear it. Kanaru said, "I believe in you." I do too, Gabe. You got this.
So first thing we're going to do
I love a Mario fam.
Inside of our scene view here, we're going to click and drag.
And you specifically, Kanaru.
This block here.
You're awesome.
And we're going to...
And KMR, always here for the streams.
Small. I'm going to click back
contributing
on
some questions and
going to change
input on it as well.
To, let's say...
Oh, all right. Virtual hugs. Do we have a hug, Maru?
So change that to pixel speed
off
to 50
music
by clicking on there.
Here, I'll help you here. I'm just going to set global music down.
This here, and we can just click and drag
Oops, that's not how you do it.
just so it fits.
Let's
And this
try to
is
make
another
it
reason why
15.
crappy art is good for prototyping. Everything is all good.
How about that, Gabe?
And we're just going to go click on the prototype
we're still
art
watching
underscore
this
one, the
YouTube video.
thing that we just brought in the ground, and
You
we're going
can't
to click
hear
add
it.
component.
Right-click on it and click mute, unmute. You
Are you
can
try-
right-click on his screen share and unmute. Okay. Gabe, are you going back and doing stuff?
I'm having a hard time hearing him and you talking.
I'm sorry.
It's okay. I'm just like try to manage it all. I turned you down.
Hold on, I have a workaround for sharing this and OBS if you want to know.
Okay, what's up?
Change your camera input on Discord
Okay.
to the OBS virtual camera.
Okay.
Is it showing up as an option?
It did. I just now my screen. Yeah, you can see. I think.
No.
No.
Oh yeah. Well, you got to change the camera, not the screen. The camera.
Yeah, I did OBS virtual camera. The only thing I noticed is that it made me disappear, and I'm seeing just the Discord background.
Oh, change the virtual background. That's why. I forgot about that.
Change windows.
Just under the settings for it, like this, the filter. Yeah, I think it's like change background.
Yep.
Always a good morning to see you lovely individuals in chat. Toby! Hey, welcome! Good to see you. Hope you're feeling better.
All right. Well, I'm lost as to what anyone is seeing anymore, but I
No,
hope
it's perfect. We're seeing
it's
the YouTube
perfect.
video, we can hear it, and we
Okay.
can see your whatever's on OBS. So basically,
Okay.
you don't have to worry about.
All right, so I'm going to drop that back just a second. He did something where I think he stretched that tile.
Okay.
So let's see.
Okay, so we got this here, and we can just click and drag this out just so it fits. And this is another reason why crappy art is good for prototyping. Everything is all good. And we're just going to go click on the prototype art underscore one, the thing that we just brought in the ground, and we're going to click add component. Wait for my beat up MacBook Pro to hurry up. And then we're going to type in Box Collider 2D. And you'll see on there that it actually creates a small, you probably can't see actually, but it creates a small box collider around the actual object. And this is why physics will work.
All right, y'all. There we go. Okay, so right clicking. So we just applied what's called a box collider. A box collider essentially is what's going to tell the game that physics need to be applied to this object. So right now, if I were to have Mario running along, if there was no box collider on this, he would just fall straight through the floor and into the infinite void. This is what distinguishes, for instance, what is something in the background of the game versus something you can interact with in the foreground. So if you think about with enemies, for instance, when you bump into them, the game knows that you bumped into them and it hurts you. That's because the box collider of your player object is running into the box, or not always a box, but the collider of your player object is running into the collider of the enemy. And that's what tells the code to run the functions that calculate things like knockback and damage and etc. So that's what we just did. We took this image and we added a component, that component being a box collider, and now this is going to have a physics. It's going to actually be something in space that has some solidness to it.
For us now. So next thing I want to do is drag in our player. There he is. Now he's a bit big, so we're just going to make him 0.5 and 0.5. I think that's good enough for now.
All right, so because I didn't have this person's sprite sheet, I don't have this player, so we're just gonna make one. I wonder if I can like stitch this guy together somehow. This is our player. We're just gonna call him Incredulous Wonk Face. He's our player, so that's what we're gonna use for our player object. We'll swap him out for something better later, but let's just keep things moving.
Doesn't matter. Once again, guys, this is up to you. We can rename it as well. So let's call this player, and let's call our original ground that we put in ground. Okay, cool. So in our
Okay, so let's take a look on the left-hand side here. It looks like I've got an extra tile hanging out somewhere. Oh, that's this guy. Oh, that's tile 56. Where's tile 0? Sneaky tile hanging out somewhere, y'all. Can't have that. Huh. Well, I'm just gonna delete him. Hidden? He is hidden. Alright, well, I don't know what that sneaky tile is trying to do. But he's not hanging out in my game anymore. We're just having this tile. And we are going to call it ground as he recommended. Call our little wonky face guy our player. Alright, moving on.
scene, we got the main camera, which is what makes our gameplay, the ground, and the player.
Wait, are y'all seeing me at all?
Not you, but we're seeing the video.
Ah.
We're seeing the game dev.
No. Okay, we gotta get back over this. And
What are you freaking out about?
alright, you're seeing my screen now on the left, right?
We see everything from OBS.
Okay, great. Okay, so now I just need to get the YouTube back over here. Alright, you should...
We see the YouTube. Don't
Okay.
worry, the YouTube's good.
Awesome. So you got YouTube on
I see the child. I see the child of Phineas and Isabella from Phineas and Ferb.
Okay, so now y'all are seeing the screen. I'm actually editing on the left, and it's not just me hitting pause every other time, so it's saying I'm doing stuff. Yes! Okay, we are good to go.
So add some physics is quite easy. We can just get the player, add a rigid, well, let's actually add a collider first. Let's just add a box collider for simplicity's sake. If you look, you'll see that it doesn't quite match the character, but that's fine. This is just for prototyping. This is just for testing it out.
All right, y'all. So I'm just going to try a little experiment real quick and see what happens. I'm going to hit play on this. I did nothing. I would have done nothing. I was expecting for the game to start running, and it's got to fall through the floor.
Infinite windows.
Seriously?
Yeah, on OBS. It's showing.
No, that's not me. Oh. All right. You should be seeing me up my game editor on the left and OBS on the right.
Yeah.
Okay. Now you're seeing the YouTube on the right.
Mm-hmm.
Okay, got it. Okay. I am perplexed as to why running the game scene is not starting the game. What I'm trying to demonstrate to y'all is that if I didn't put a box collider on my little dude on the left, if I hit start game, he would fall through the floor. I want to add a collider to make him not do that. But I am very concerned as to why it's not running at all. It's just literally doing. Oh, and it crashed. No, it didn't crash. What are we doing wrong? Main maybe got a camera. Got a camera, got ground, got player. Well, I've never this issue before. Alright, well, we're gonna try closing Unity and opening it back up again. Wait, oh no, okay. I think I figured it out. Alright, here we go. Let's turn off play mode, add component. Alright, so we're gonna add a box collider like it said in the tutorial. Adding a box collider to the player. And so again, notice these little points. So these little points are what it's saying is your box collider might not have to necessarily be the exact same shape as your object. So for instance, if I select the collider to do that. Why is it changing the shape? I don't want it to change the transform. Okay, there we go. So if I wanted to, I could create a collider that's bigger or smaller than my object. And this might be something, for instance, let's say I had like a power that was like a damage field or something like that, right? I might want it to extend beyond the edges of my character. So basically the idea here that the application of the physics doesn't always have to necessarily match the image. Let's go a little further and see what happens.
We're not even going to worry about the legs at this stage. We're just going to leave it as is. Next thing we're going to do is we're going to add another component called a rigid body 2D.
Ah, that's the issue.
And we're going to make collision detection continuous, start awake, and constraints, we're just going to freeze the rotation.
Okay, so the collider is going to define the boundaries upon which physics are applied, but what I didn't actually do was add the physics itself. So first thing I'm actually going to do is I'm going to remove this component. I'm going to add a box collider. So that's all good to go. I actually just want to experiment with this. Yeah, I can do whatever I want. Okay, so I've added the bounds upon which physics are applied. Now I'm going to actually tell Unity to apply physics to this. And so that's what's called a rigid body. Rigid body 2D. Adding that. Let's see, he had us set it to continuous and lock the Z. Why are we locking Z? Because it's a 2D game. We don't want things to be knocking me towards the camera or away from the camera. All right, so now, if my hypothesis is correct, all right, you see how it fell? All right, I'm going to show that again. That's whoa, this is some crazy stuff, y'all. Right. Okay, so I'm floating in space, and then when I hit play button, it's going to apply physics, right? So when I apply physics, all right, it's pulling me down toward the ground. Now I want to demonstrate, again, this notion of sort of box colliders in physics. I'm going to go back to this ground element, and I'm going to turn the box collider off. So that's going to say, don't interact with the physics if I don't have it on the ground. If I hit play now, oh no, I just fall right through the bottom, right? So adding colliders is where the application of physics is, and rigid body tells the game which physics to apply. So I'm going to turn that back on. And there we are. Okay, so look at that. We got a character, we got a camera, we got ground. We're ahead on our way of making a 2D action-adventure platform. Let's continue.
We don't want him to rotate, and we're going to leave all the rest of this. Okay, so when we press play now, the character should move down and collide with our surface. So ta-da, we have a game with physics, and that was pretty simple, pretty straightforward. Our character falls down. But to actually do anything with our character, to move him around, we need code, obviously. So that's the next thing that we'll be jumping into. But before we do that, let's just save it. File, save scene, save project. We want to make sure that we're always doing that. And let's just straight away open up some code. So we want to create a new C# script, and we're going to call this player _ move _ prototype.
Oh no.
Okay. It just helps us let's just create a public. Okay, to start, let's just straight away open up.
All right, y'all. So now we're going to start doing some code. Oh no, does Gabe know how to code? Kinda. I know how to code enough. So we're going to be creating a script in C Sharp. So C Sharp is the programming language that game design happens at least in Unity and in many places as well. So yeah, we're going to go ahead and do that. So let's go ahead and create a C Sharp script. And as said, let's call it, they call it player movement. Cool.
Some code. So we want to create a new C# script, and we're going to call this player underscore move underscore prototype prompt, whatever you want to call it. But basically, we're going to. So how I'm going to set this out at the start. We're going to create a quick and simple, dirty way of doing things, and then we're going to actually iterate on that in the future. To make the physics better, because we can use custom inbuilt physics inside Unity and it will be okay, but it won't be. It may, but it may not give us all the control that we want. So basically, yeah, we're going to start out really simple, get a character moving. If this is your first game, you'll be pretty stoked, and then we're going to go into some more complex stuff. So let's open up the player move script. Okay, to start out here, we're going to go really simple to start off with. So let's just create a public variable, public int player speed.
All right, so I just discovered that this is going to open Visual Studio, which means yet another window. So we're just going to open this on the right-hand side, and we're going to do the best we can. Of course. Seriously. Of course, I'm gonna forget my password while I'm streaming. Try this one more time. Try not to get locked out of my account while streaming. There it is. Just bad at typos. Take a moment to take a peek at the chat and see if anyone has any questions or thoughts about anything. Let's see. Is there a way to focus on his Unity screen only? I have to get Gabe to do it, but I don't want him to do anything else right now. I appreciate that. Yeah, there's no way I'm doing this again without 3 monitors. Just FYI. Oh, good. This isn't logging me in. Let's see how this works. All right. Well, we've got some other cool stuff coming up while we wait for Visual Studio to finish loading. I hope y'all join me at 4 o'clock today. We've got our interview with Dr. Adam Dipert, and he is just incredible. He is a PhD in physics who he works in the circus, trapeze, tightrope, juggles fire. You have no idea the amount of things that this guy does. It's really incredible. Yeah, so definitely check him out. He just finished doing a 10-day silent meditation retreat called a Vipassana retreat, where they basically put you in a tiny room for 10 hours at a time and make you just do body scans. So you know that little body scan meditation that we do for like 10 minutes at Amaru? Imagine doing that for like 10 full hours a day for 10 days. And you can imagine that that might be a pretty interesting experience. So, yeah, I definitely think you should check it out at 4 o'clock. I'll obviously be streaming it on all the places as well. But Adam is a personal friend and really interesting guy, and I think he has some really cool wisdom to share with you all from that experience. And this is still loading. Speaking of 10 hours, I think Visual Studio is testing whether or not we can wait around for 10 hours. This is interesting. I'm gonna hit cancel and try again. Also, I don't know why it's preparing for first use, because I've definitely used it fairly recently to prototype a version of Flappy Bird. Oh, see, it just needed a little encouragement. It just needed a little bit of additional love. There we go. All right, so Visual Studio is now here. So this is the program that we're going to be using to edit our C# scripts in Unity. So as said before, we are now creating a movement controller. So this is going to be the thing that's going to receive inputs from us that translates it to the machine so we can actually make our little boy move around on the screen. And let's continue with the tutorial. Let's see how it goes.
We'll need a public bool, and we're going to call this facing right. So the reason we have this is we just have just a public bool which equals to true or false that just says is the player facing left or right, and if he's facing right it'll equal true, if he's facing left it'll equal false. It's pretty simple, but it just helps us determine which way the player is facing. And we're just going to have another public float called, let's make this an int actually, int, and we'll make this player jump.
So what's happening here, y'all, is we're doing a step in programming called declaring our variables. So before you can tell a program to change anything, you need to tell the program what to be paying attention to. And so that is what we're doing here. So this public class player movement prototype, we're going to be creating variables underneath that. So let's see, I'm going to go ahead, I guess it's right here within this curly bracket. I need to get on that old, what's it, GitHub Copilot program that they've created. It's like an AI helper for your code. You don't make terrible little mistakes all the time. Nope, that's not what I wanted. Here, speed. Right. And as he was saying earlier, these three variables are going to be determining, I'm guessing, actually, you know what, I won't jump ahead of him. He's going to explain what's going on.
Power.
Player jump power.
Cool. So let's assign these variables. So let's assign the player speed to 10. Let's assign this to true. And let's assign the integer to, let's go really high, 1250. I plan on using some 1250 equals 1250. Okay, cool. So now we don't, I don't think we'll need start at this stage. I'm going to zoom out a little bit. This is making me a little bit insane having that text that high. Okay, then we're going to go to update, and we're going to create a new method inside update. So update runs every single second, so every single frame that the game is running. So we want our player to be able to move every single frame that the game is running. So we're going to create a new method called player move. Oops, it autofilled there. Player move. And down here, we're going to create that method void player move. Okay. So inside player move, we're going to have a few seconds. We're going to
Just going to pause for a second to make sure I get that right, because every single character, if it's correct, will cause a compiling error. Which is also a beautiful thing about code, because it will not let you get away with anything. Okay, so void update. So as you said before, we want there to be code that runs for every frame of the game. So that's what we'll be doing by having this update function running. And when the update function is running, it's going to be checking constantly whether or not it needs to be running code for our player movement. It does like to do that autofill. Default it. I try when I'm following tutorials to name everything like as close as I can to what they're doing, just for so terrible. Okay. Let's see what he does next.
We're going to have the controls. We're going to have the animation. We're going to have the direction. Actually, we'll call this player direction. And we're going to have the physics. Cool, and we're going to create another method called jump. So void jump. Jumping code. If you're new to coding, my only advice is just to keep watching tutorials, just keep learning, don't get frustrated, you'll eventually get there. This would have been way over my head when I first started, but how I found that I got a lot better when I just kept watching tutorials and things like that.
So, little note for those of you who aren't coders: anytime you put a double slash in front of code and you see it's turning green in my editor there, that is creating what's called commenting out. So it allows you to have little notes to yourself, which is really good practice so you don't get lost. And it also is easy because if you just want things to like not run, you can just put 2 slashes in front of it and it's called commenting it out. So this will allow us to kind of help keep our documentation for ourselves clean. All right.
I really loved Quill18. If you want to check out him, his tutorials are really, really good. Again, so controls, we are going to, actually, we need to create a new variable first. So let's go to up here and go public float move x. Like I said, this is a quick and dirty way of doing it, but this will get us up and running really quickly. So we're going to just write move x, which is this variable that we just assigned up here, which is short for movement on the x plane, is going to equal input dot get axis horizontal. So we type out just like that.
All right, so now we're starting to talk to the Unity game engine. So the Unity game engine's already got a lot of different instructions in it, and it knows, for instance, what input.getAxis means. So what we're doing here is we are telling the game that in order to move, we need to look for an input and get the axis of the input, which is horizontal. So it could be vertical, it could be or I guess on the Z transform or something. But we're talking about moving on the X plane, which is horizontal. So we want to get the horizontal axis.
It should all be good. And we're not going to worry about animations just yet. We're going to say inside play direction, we're going to say if move x is less than 0.0 f and facing right, which is this boolean that we created up here, equals false, then we're going to flip player. So flip player. Now that won't load for you because we haven't created that method. Let's create that down here. Void flip player. Cool, so now that should be spelled exactly the same, look exactly the same as that. So basically saying if our moveX variable is less than 0.0f and we're facing right, and we're not facing right, then flip player.
All right. Get caught up here. Hard to do this when I'm watching a tiny little screen. Trying to keep everything visible for y'all, doing the best I can. All right, so we're creating a new function, flip player. All right. All right, let's see. All right, if move x is less than 0f, is greater than 0f. Okay, so that means that we are moving, right? So 0f, what does that mean? Well, we defined up earlier that move x would be a float. So the f is a floating point, which means it's not a hard integer. So anytime you're not going to have something that's 1, 2, 3, 4, 5, you might want to use a float. And that would definitely be the case with how much we're moving. So we want to make sure that if we are moving, which means that that value is greater than 0, and we're facing to the right, we're going to flip. Might be a piece of this I don't know yet. All right, I like to get ahead and try to teach myself, but I'm just going to let it run. Let's see what comes next.
And then we're going to have another, we're going to have an else if here. Move x is greater than 0.0f. Sorry, greater than 0.0f. And facing right equals true. Then we're going to flip player. Cool. So it's
Let's see. It's true. To me is doing this in a way that I don't quite understand yet. So let's see how he ties it together. All right. If move x is greater than f less than, and facing right is false, and facing right is true. Okay, so what we're basically doing here is determining the player's direction. I guess I'm just not quite sure. He did say that defining movement as his float was sort of a quick and dirty, and it definitely seems that way. So let's see what he wants us to do with that. It looks like I am missing a curly brace right here. Probably some other ones too.
basically saying like that, saying, you know, if we're facing one way and then we move the other way, it's going to flip player. If we're facing the other way and we want to face the other way, it's going to flip player. Don't worry, it'll all make sense in a little bit of time. And then the last part is physics, and we're just going to literally control the character the quickest, dirtiest way. Game object dot get component. So we're accessing a component. I just want to quickly explain this a little bit. When we say game object dot get component, we're accessing something on the component that the script is attached to. So if the script that we're creating is attached to the player game object, it's going to access one of these components: the rigid body, the box collider, or the sprite renderer.
So we haven't done this yet, but what's going to end up happening is we're going to be dragging these pieces of code onto individual objects in the scene. So that's what he's referencing here.
Providing that we have them. So we're saying GameObject.getComponent, rigid body 2D, and we're going to just access the velocity. That's going to equal a new vector 2, which is equal to movex times player speed, which is this variable up here, comma, game objects dot get component rigid body 2D. I'm just going to zoom out a little bit. Hopefully you guys can see that. Dot velocity dot y. Close bracket, and there we go, done. and make sure you do a semicolon at the end. And that's the
All right, let's see if I, not if I messed that up, but where I messed that up. All right, we got to close paren and dot y there. That paren and semicolon. Okay, so what we're doing here is we are referencing a bunch of Unity scripts for Unity libraries. We're fetching physics, we're fetching the velocity, and we're talking to some of the variables that we defined earlier up here, like player speed. So let's see, I just need to just over here so I can my code a little bit here. Which body 2D? Yep, there's one mistake already caught. Vector 2 x times speed, comma, game object dot get body 2D velocity dot y. Okay. That's why it's getting dot y. Dot. All right, haven't programmed the jumping code yet, so that's just the physics. Oh, because we're only going to be falling. That's why we're getting one. Okay. Else if, all right, player move ends up being just one big logic puzzle. Player direction. If move is greater than row F and facing right, false. Cool. What's that? That's not right. Aha. Found a mistake. Oh, gotta do equals. Let player greater than the if. Okay, I don't know what this is. This is if x less than and facing right equals false. There. Flip player, boop, boop, boop. All right, that's all looking pretty good. All right, now back up to controls. Move x equals input dot get axis horizontal. Cool. All right, haven't done anything in the animations yet. Okay, probably gonna save this, and it's gonna tell me that's angry. But let's move on back to the tutorial for a second and see what next steps are.
That's the total line of code that it gets the player to move left and right. So we should probably test this out before we go any further. So if you go back to Unity and we go to our player, we can click Add Component, type in player, and our script should be there, or you can just click and drag it on, whichever one you want. And we got you can see we've got our variables here, our player jump power, our move X, and our player speed, and we can just press play.
Okay, so I don't think that works. It's supposed to. And the reason I don't think it's supposed to is because I'm not seeing these public variables. So what did we just do? We just assigned this script to the player object. So we didn't put it on the ground, we didn't put it on the camera, we put it on player so that this physics and this logic applies only to this player object. But when you define a public variable, you should see it pop up in the dropdowns here. I'm not seeing that. So let's find out where I went wrong.
And our script should be there, or you can just click and drag it on, whichever one you want. And we got you can see we've got our variables here, our player.
Okay, so back.
Get component.
All right. Public class, player movement, mono behavior. That's all correct. Public int player speed. Oh, maybe it's because I just didn't finish saving. All right. Let's try that. Try closing this out. Yep, aha. Because we had errors. Of course we did. All right, great. So back over to my script. Discover. Why did it not? All right, so fun things about, wow, okay. Let's try this again. Clear concept. So many things are broken. In class, okay, asset player movements error 46.1. Let's try that. What we got? 46.1. Like clear out. Here we go. Get rid of all that. Type or name this definition. This one. Okay, try this. Save again. Oh, maybe it's like Tyler error is most obvious. Okay. Asset player movement prop.cs 40.1. So that says this curly brace. Oh, there's definitely an extra curly brace, I think. It was really hard trying to follow that along out with that YouTube streaming, that's all. Let's try. I'm gonna just try looking again. Here's just really riveting stuff. All right, let's see. Go. Here. All right, so okay, well, we're off to a good start. We have our defined variables, player in, player speed equals 10, cool. Public bool facing right equals true, correct. Public in, player jump power, 1250. Public float, movement X. We think we're pretty safe there. All right, we commented out this stuff. Now we're down to void update. Here is my curly brace for that. So for those of you who don't code, curly braces are kind of what keep chunks of code together. So if you get those out of place, it gets everyone all confused. All right, player move. Okay, that curly brace should probably not be there. Aha. All right, so that's one problem we have discovered. That should not be there. Yep. Okay, great. So still haven't done anything with the animation. Still got player direction involved here, all within the player move function, which is why we wouldn't want that curly brace closed, because we want all of this to be in the player move function. I wonder if that'll do it. Let's just give it a try and see. Usually I'm not that lucky. Usually there's at least one. Let's find out. Oh, okay. All right. Well, made progress. Fewer errors. All right. There's an else statement issue, so let's get back over to it. All right. So we were in the player move function. Move x input axis horizontal. It said something about like else statements. Let's take a look here. In player direction, got if move x less than. Okay, flip player. Else if, aha, there it is. We have a missing curly brace here. All about them curly braces. Let's try that. How you like that, Unity? Oh, all right. Only one more. That's good. Fewer red lines. I used to be a teacher. They used to say like not to grade people's like stuff in red because like me hurt their feelings. I did it anyway. I don't know. It's just good feedback. Hate me in the comments if you want. All right. So facing right equals false. Flip player. Else if. Okay. So now we're on to the next line. Else if. Okay, move da 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 da. That seems to be right, as far as I can tell. Okay, I think I'm missing a curly brace at the end of this guy right. I think that would close out player move function. Yep. 4626. What's that? Okay. What's going on with this void? Looks like it. Looks like there needs to be another curly after it. Compiling. We have compiling. More problems. All right. The name player move does not exist in the current context. That's line 22. Okay, 22 player move. Why is that? It's because void update. Got that there. Okay. Void update player move. Boop boop. It's because I have this underscore in here. Where did we define player move? Void player move. Weird. I would think I would have to define that earlier. Oh well. It's like Publix or something. All right, so back to Unity. Compiling. All right, one more down. All right, 44. Hyper namespace rigid body 2D could not be found, probably because I just typed it wrong. Rigid body 2D. Is it not that way? Let's go.
Hey Gabe, are you
Yep.
able to change the ratio between the coding screen and the Unity screen?
I don't know. We're about 4 minutes left on this, so I think we'll pretty heavily overhaul how this went for the next stream.
Okay, fair enough.
Yeah, but thank you for the suggestion. All right. So I'm looking at I would love it if we could squeak across the time here with a error-free compiled script. That would be just dandy. Let's see what I'm missing here. Rigid body 2D is. Yeah, I'm not doing this without 3 screens. That did not work. All right, get component, rigid body 2D. Okay, yep, there were supposed to be a little bracket or little parens here. I missed that. Let's see if that'll do it. All right, only one left. We are getting so close to having a compiled script here, y'all. All right, we are at line 44. Same place. Oh, it's weird. I thought we just fixed that. Could not be found. The type or namespace name rigid body 2D could not be found. It is on the line twice. We fixed it in place. All right. Let's see. Game object, get component.
I think you've got a capitalization issue.
Do I? Oh, I sure do. Thank you for catching that. That is all it's going to take. All right, back over to Unity we go. Oh no. Oh, is it lowercase b at both places, baby? How does he have it? Yes, it's lowercase b in both. Outstanding. I'll also be sure next time. I guess Visual Studio forgot all of the Unity commands since the last time I worked on it. It would help. It would be helping me, but it did not
really
today.
See the code.
Oh, yeah, for sure. Okay, all right. On the left-hand side, we are now error-free, which is exciting.
Chloe had some advice.
I'll bet.
If you'd
Chloe.
like, you can gave some code.
What's that?
Chloe gave some code.
Oh, outstanding. Well, we did it, y'all. Right here at the buzzer, we learned a lot today about streaming and screens and how this can be done better next time. I appreciate all your patience. But we from the time that we started this project last week, we came to a blank canvas of a Miro board. I'm gonna switch my oh gosh, do I dare try and switch my view right now? I just want to show yeah, I'm doing it. I'm gonna try this.
You're doing it.
All right, are y'all seeing Miro on the left hand side?
On the right.
No, we're seeing.
Now you are.
Nope.
Nope, you're not. You're still seeing Unity. Ah.
Just switch back to a plain old live scene. The live scene.
Plain old live scene. There we go.
There we go.
All right, so we started, this project last week with just literally like, we don't know what this game's gonna be. We know that it's gonna try to achieve these emotional goals, and then we kind of prototyped out some stuff like in a completely not at all game environment. And then, by the end of the day today, I mean, there's a lot of like figuring out the technical side of stuff, but we now have, for your pleasure, this lovely box character, our new little friend, and he's sitting with physics applied on a rigid body on the ground, and apparently the starts of the movement controller that did compile. So we're definitely going to do some work on how to make this stream more seamless in the future. I definitely need to install some plugins on my script editor and figure out probably a 3-screen solution so I don't have to do what we just experienced. But yeah, this is the nitty gritty. This is the stuff. This is how we start small, but I'm hoping by the next time we talk. I don't actually know because I don't know what I know, but what it says it's using get input, but I don't know what the input is assigned to.
Oh.
Like maybe Chloe has a suggestion.
Pull up the code on the main screen for a second.
Pull this code on the main screen.
Possible if that's not a huge.
Oh, I don't know. Are you seeing it?
I mean, it's on the tiny screen. Can you just read the line to me that says get input whatever?
Sure. Game object get component rigid body. Wait, where is it getting? Oh, move x equals input dot get access horizontal. Get access horizontal.
Okay, so that's going to be your left and right arrow keys.
Okay. All right, y'all. Let's see. Ball. Can you do it? I'm not getting anything.
Did you click on the game screen?
I thought. Wait, yeah. Hit play. I am hitting left. I'm not getting anything.
Oh no.
All right. Well, until next time, y'all. we clearly have a lot to figure out. But yeah, when we're not spending 75% of the time fighting with the tech, I imagine this will go a little bit faster.
Great try.
But cool. All right, y'all. Well, thanks for that. Hope that was enjoyable in some way, shape, or form. Come back at 4 o'clock today. We've got Dr. Adam Diapert, and he is an absolutely incredible man. Like I just said, physics extraordinaire, juggles in space. Like literally, the juggling that he does in zero G has created new math that NASA is now using to like figure out how stuff happens in weightlessness. So he's going to be with us, and this is a guy who, I mean, he believes in physics and being embodied so much that he's willing to throw himself off of a trapeze, because he just knows if my mass is this and my direction is this, then I can fly through the air and I'm not going to die. And he decided to meditate for 10 straight days for 10 hours a day and came out with, I think, was a really empowering message that I think all of you could benefit from hearing. So tune in at 4 o'clock today, and it will be a good time. And there's only one screen, so it's gonna go real good.
Sweet. All right, guys.
All right, thanks everyone.
All right, thank you guys so much, KMR, Connor, Chloe. We'll see you guys later. Have a good day.
All right, bye-bye.
Switch to that ending stream, and then you can just end after a minute or
Sweet.
a few seconds.
Sounds good. What's that? Screen.